Early decentralized networks often suffer from a specific structural flaw. They build a highly functional product that generates immense real-world utility, but the underlying token economics operate in a vacuum. The network spins, the users benefit, but none of that economic energy transfers to the asset holders. Akash Network currently generates $3.15 million in verifiable annual revenue. That is a concrete metric of compute demand that most decentralized AI projects cannot match. Prior to the AEP-76 upgrade, the network's tokenomics ran on a simple, isolated track. The system minted new AKT every block as staking rewards, resulting in an 8% maximum annual inflation rate. The protocol did charge a minor take rate, 4% on AKT payments and 20% on USDC, but those fees were simply diverted to a community pool. This structure offers no mathematical benefit to a token holder. If a tenant deploys $10,000 of compute on Akash under this old model, it creates zero direct buy pressure for the AKT token. The compute marketplace and the AKT token existed in complete economic isolation. The product worked, but the token simply inflated. On March 23, 2026, Akash alters this architecture by activating AEP-76, integrating a mechanism known as burn mint equilibrium directly into the main net. Burn mint equilibrium, or BME, replaces the straightforward inflationary model with a dynamic system where supply expands or contracts based on direct network usage and asset price. The new architecture introduces a strict mechanical rule. Every single dollar a user spends to rent compute resources on Akash must now actively remove AKT token supply from the open market. Instead of skimming a marginal take rate fee off the top of a transaction and sending it to a separate pool, the BME model captures the entire transaction value and routes it straight through the token's circulating supply. BME establishes a permanent, mathematically verifiable link between the actual usage of the Akash network and the circulating supply of AKT. The mechanism executes in two distinct phases. The first is the mint phase, which triggers the moment a tenant funds a compute deployment, paying either in fiat currency or directly with AKT. The protocol takes that payment and immediately burns the equivalent amount of AKT at the current Oracle price, permanently destroying those tokens. An oracle is a decentralized data feed that brings external market prices onto the blockchain. To represent the value of the destroyed AKT, the protocol mints a secondary token called ACT, or Akash Compute Token. The exact dollar value of the burned AKT dictates the amount of ACT generated. ACT operates under three strict constraints. First, it is soul-bound, meaning it is permanently locked to the user's wallet and cannot be traded on an open market. Second, it is pegged precisely so that 1 ACT equals $1 of compute credit. Finally, it is fully refundable back into AKT at the current Oracle price if the user cancels the job. While the compute provider completes the assigned work, the ACT sits in an over-collateralized escrow. It acts as a temporary sink, effectively holding the burned AKT out of circulation. The second half of the mechanism, the settlement phase, activates the moment the provider successfully finishes the requested compute task. The protocol takes the outstanding ACT escrow tokens and incinerates them. To pay the provider, the protocol remints new AKT based on the settlement TWAP. TWAP stands for Time-Weighted Average Price, an algorithm that calculates the average price of an asset over a specific period to prevent sudden market manipulation. This establishes the core equation dictating total supply change. Net supply change equals 1 divided by the mint price minus 1 divided by the settlement price. Let us run the math. A tenant funds $1,000 of compute when AKT is priced at $1.14. The protocol burns exactly 877.19 AKT. If the provider finishes the work when the AKT price has climbed to $1.50, the protocol only needs to remint 666.67 AKT to pay the provider their $1,000. The result is a permanent net burn of 210.53 AKT. The price appreciation between the start and end of the job means fewer tokens were created than were destroyed. The network's token supply now moves as a direct mathematical derivative of price action during the compute lifecycle. If the price rises during a job, supply shrinks. If the price falls, supply expands to cover the provider's payment. That last point exposes a specific mechanical vulnerability. If the price of AKT collapses aggressively while a compute job is running, the protocol would be forced to remint massive amounts of new tokens to make the provider whole. To prevent hyperinflation, Akash built the BME Vault. This buffer pool intercepts and holds AKT from the initial mint operations before destroying it, allowing the protocol to absorb severe market volatility. The system constantly calculates the collateral ratio, the total value of the vault's AKT, divided by the outstanding ACT compute credits. If the ratio drops to 0.95, the system triggers a circuit breaker warning. If the value hits a 0.90 ratio, the protocol initiates a hard halt, physically blocking any new ACT mints. This architecture forces a strict priority. During severe market stress, the protocol will halt new compute onboarding to guarantee the solvency of the overall system. This dual bar chart compares Akash's nominal token inflation against the new reality. On the left, you see the baseline 8% inflation. On the right, factoring in the current $3.15 million in usage, the net burn drives the effective inflation down to approximately 5.2%. For compute providers, the BME upgrade eliminates the old tax structure entirely. The protocol abandons the 4% AKT and 20% USDC take rates. In its place, providers face only a 25 basis point spread on the mint side. A basis point is a unit of measure equal to 1/100th of 1%. In return, their payouts are exclusively denominated in AKT. Previously, providers accepting fiat payments had no direct token exposure. Now, by receiving AKT, they become mandatory participants in the token economy. Increasing compute usage now drives simultaneous benefits across the network. It improves the margins for the supply-side providers, while mechanically reducing the dilution faced by passive token stakers. To understand the specific choices Akash made, we have to look at the primary alternative in the decentralized AI sector, Render Network. Render uses a decoupled BME architecture. When a tenant burns tokens, those tokens disappear. Provider payouts are entirely independent, funded by a separate fixed emission schedule. Akash utilizes a coupled architecture. The specific tokens burned by the tenant directly dictate the specific tokens reminted to the provider, with the spread determined by the central price oracle. Render's model guarantees a hard supply cap, enforcing eventual scarcity. However, it currently suffers from a structural gap, where fixed emissions outpace burns by a factor of 8. Akash lacks a hard supply cap, leaving the total supply as a moving target. But the coupled design actively accelerates deflationary burns during a bull market, where a rising price forces harder token burns. The engineering choice is a direct trade-off. Render guarantees slow-moving scarcity, while Akash creates a dynamic engine that amplifies prevailing market trends. We must address the mathematical reality of this upgrade. The implementation of BME does not instantly turn AKT into a deflationary asset. This line graph maps Akash's annual compute revenue against the net change in AKT supply. At the current $3.15 million in annual revenue, the effective inflation remains clearly in the positive zone. BME requires serious volume to cross the threshold into outright deflation. To outpace the baseline staking rewards and push that supply line below zero, network revenue must increase by nearly an order of magnitude, pushing past the $10 million mark. Despite remaining inflationary, the upgrade instantly manifests $3.15 million in direct on-chain buy pressure for AKT that simply did not exist before the activation. AEP-76 creates a direct on-chain demand sink, building the architectural foundation for value accrual before the network reaches net deflation. Akash has shifted from an isolated utility layer into a mechanically synchronized token economy. Demand for compute hardware now mechanically drives the economic velocity of the network's native asset. Only one requirement remains for long-term value accrual. The network must aggressively scale its tenant compute demand to trigger the deflationary crossover. AEP-76 is the necessary foundational architecture. Without this exact mechanism locking product usage to supply destruction, no decentralized infrastructure network can justify its long-term token valuation. This analysis is from Own Your Mind at ownyourmind.a.a, an independent research platform covering decentralized AI. No sponsors.